This is Mariusz Konieczny. Welcome to another video in the Aduro video series. Today, we are talking with Derek and Billy from Exergy. Thank you guys for joining me.
Thank you.
Thank you.
From what I understand, Aduro and Exergy, you guys are working together on a pilot. Am I correct?
Yeah, that's correct. Yeah.
For my audience, could you maybe take a few minutes to describe who you are as a business, what you guys do?
Well, Exergy, we're a technology commercialization partner, and essentially we provide engineering, design, fabrication services to build pilot plants. So at the core, we take technologies at different TRL stages, but we really like to work on the ones that have good commercialization potential. When we build pilots, we have some unique capabilities in our operation, like additive manufacturing, for example, where we can print in different exotic materials and different shapes and sizes, and it really helps the pilot process move more quickly. Sometimes we see a customer that's stuck, and then we print a part, and it really gets their technology unstuck. So it's kind of a unique advantage that we have.
We take that, for those that don't know, TRL is technology readiness level. It's kind of a definition that everyone's kind of agreed on of where a technology lies along its developmental curve, right? So we like to get a hold of companies around that TRL 3, TRL 4, which is they've proven that either the chemistry or the product works at like a small scale, and they're trying to figure out how to go a little bit bigger to make that next step up to say, well, we've proven that this works at a small scale. Let's go a little bit bigger, and bigger can be somewhere around a liter per day, or it could be upwards of a couple cubic meters a day of process, or kilograms or tons a day. So that's where we kind of excel in that area.
That's actually, I guess, where Aduro is, because they did prove up the chemistry. That's did right. Prove it up in the batch system, right? And then now the next step is to prove it up in a continuous fashion, and that's where you guys come in.
That's correct. Yeah, we're helping right now. We're looking at that those kinetics that they've got and seeing how we can best go forward to make this either a system changer or a game changer, or make it competitive to other technologies out there and be able to actually process at the size they need to be to make it successful.
Yeah, Mariusz, you mentioned continuous flow, and that's exactly it. Because once you get away from the fume hood or the batch process, you want to actually mimic a real commercial operation, but at a smaller scale. So you need all the piping and instrumentation and automation, and to get a continuous flow, so you can control the process, control temperature, pressure, and the reaction, and really allow to get a more steady operation that replicates what you would see at a commercial scale.
Can you explain to a fifth grader what's the difference between a batch operation versus continuous flow?
So batch is where you take all of your chemicals, your stuff, and you do one thing, right? So you put it all into a container, and you shake it up, or you do whatever you're going to do to it. Then it comes out the back end. Now, whether that's a chemical process or whether you're making a desk, like even if you're making a hardware item, you just make that one item and you say that's what we want it to look like, but you can't possibly commercialize that based on that one batch process. You have to figure out, like, how do I make 10 desks at the same time, or 20 desks, or how do I make a continuous 1 liter per minute process?
Would it kind of be like you're maybe making a dress? You're a fashion designer. You're making a dress, like one dress, yeah, versus making a mass production of that dress.
Sure.
Yeah.
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 Yeah. You go from that one dress to, you can't go from one dress to 1 million dresses though. You go from one dress to like 10 dresses. And then you go from 10 dresses to 1,000 dresses, and then 1,000 dresses to 1 million dresses. So you have to, like, each time you scale up, something that you didn't anticipate happens. So you want to catch it so that when you're at the next level, you're not fixing everything, you're just fixing the new problems.
When I was reading the press release, when, Aduro and Exergy, I noticed that there was a conversation about pilot for upgrading heavy oil. From what I understand, and I don't know if you can answer this, that Aduro had a pilot or R2 that they did before on heavy oil, upgrading heavy oil, and now they are doing the same thing for plastic. Were you guys involved in both of these, or you're involved in just one?
We weren't involved in the direct piloting of them, but we were involved in the technology development on that. So getting it up to the next location. So the R3 reactor, I think, or R2 reactor, they did in-house, but we were involved a little bit on the, kind of the flows and the heat material balance that went into that.
Right now, what you're working on is the pilot. I'm not sure if it's only R2 or R3 also. Is it both of them you're working on?
Right now, we're trying to. We just had a quick meeting to go over the requirements for the R3 reactor. So yes, we're stepping into that R3, which is a step from the batch to the continuous reaction on the plastics process.
I think it was Billy. You mentioned that your company likes to work on projects that have a possibility of reaching commercial production. How would you rate Aduro in that?
Yeah, I mean, there's no rating system per se, but I would say what's promising about the Aduro technology is it doesn't run at super high. It doesn't have a big thermal requirement. So in a way, it's lower GHG process, which I think gives it really good potential from that point of view. Also, I think it also has potential to be more at a regional scale, where sometimes you get into these processing units and they require a lot of hydrogen, for example, and that's not the case for Aduro. So then you have to put it in a location where a lot of hydrogen is produced. But when you look at plastics and recycling of plastics, they're collected at a regional scale, like in a major city or whatnot. So then you could almost like have this process commercializable in a regional way. So then you're not transporting all of these recycled plastics across the landscape and dealing with those kind of emissions related to transportation of the plastic. So essentially, it's a lot more effective to turn the plastic into a liquid regionally and then pipe it or transport it in a very compact way in a tanker, in a liquid form. Because when you compress plastic, there's a lot of airspace, and so there's some really unique advantages to what we could see here. And I think that's why it has a really good chance, commercially, to be scalable.
And as a company, Exergy, do you guys specialize in particular industries or particular pilots?
Yeah, we've played in a lot of spaces. I mean, we've done water treatment pilots. We've done flow battery, which is a renewable energy technology. So we typically work in the energy space. So energy being industrial energy usage space and process technology. So that's our specialty. And we've worked in heavy oil as well and partial upgrading. So everything and working at a smaller scale is not always easy to build things at small scale. Things can plug, things can. So we've kind of developed some expertise in building things at that scale in energy transition kind of technologies and clean technologies.
How did your relationship start with Aduro? Like, when were you introduced to the company?
I think we were introduced to Aduro at one of the green conferences. I don't know the exact history to that. I apologize. I should have read through the notes, but that's how I got introduced. Just kind of met each other at a conference, and it kind of grew from there.
Do you hear any feedback from industry players as to what Aduro is doing? Do you have access to any of that kind of stuff?
We do, and like one of our big roles with a lot of the companies that we work with, especially on the small technologies, is that we can integrate with other larger groups, right? So anytime that we're working with a technology group, and then we meet with other big players in the industry, if we see a fit, we do mention these. So we go in and we'll say, hey, you guys need to have some plastic recycling, bitumen upgrading, whatever it is. Here's this new process you might be interested in. Why don't you go through their technical process with them, give Aduro a call and see what we can do with them, right? And we act as that kind of intermediary there to say that we're not completely unbiased, but we can also look and say, well, this technology may or may not be a fit here, and here's the reasons why. Right.
Yeah.
So we're that kind of that third party there. They can talk to a Nova or a Dow Chemical or an Exxon and say, I think this will work. Again, we want to get your product in there so you can see all the results and see what's going to happen. But let's give it a shot, see what happens. I think it's going to work, or yet it's not the right fit for this. We'll try something else.
Yeah, and generally speaking, I mean, waste to fuels is a very much in a high in demand space. Even big players that are making millions of barrels a day are interested in ability to make 5 or 10,000 barrels a day of fuel from waste. So I think attention is definitely in this sector, and Aduro is well positioned to get their attention. So I can't speak for the team at Aduro and how much traction they've received from some major industrial players, but they're all willing to invest and try and bring the technology, say from a lower TRL to a mid-sized TRL, because the reality is there's not a ton of technologies that are, say, ready to be commercialized, that are, say, TRL 8 or 9 ready to go. So big industry players are willing to play with many of these emerging technology companies that can bring it to market at a larger scale. So it's the timing's good.
The 2 pilots that Aduro is working on, I know that one pilot, according to the press release, is with Switch Energy in Canada, and then another pilot, they were invited to build a pilot with Brightland, which is in Europe. I assume Exergy is involved with building both of those pilots, and so I don't think, I think you're in Canada, right? You guys are in Canada.
Yeah, we can.
So obviously in Canada that's easy, but how do you do this in Europe? Do you just consult the people in Europe, or do you have people fly in there to Europe to build it?
No, so these pilots are generally built to the scale that can be shipped over. So what we do on most pilots that we send over to Europe or Africa or any of those locations, even Mexico, is that we'll build them in Canada or a shop near us. It could be in the US, because Aduro is located very close to the US border in Ontario. But we'll do the engineering up here. We'll get the unit constructed or fabricated somewhere in North America. More than likely, it's going to be in Canada. And then it'll be tested and kind of confirmed to the local codes. That's usually the biggest issue when you go to Europe or to any of the other ones, is that we'll build to a CSA or an ASME or API code, where we have to then get it recertified to the CE or the European mark or wherever they're going. And that's something that we've done a fair amount of, building things here and then shipping them to countries like Finland or England or France. So it's something we're very familiar with, and that's usually how it happens. To get it to be built over there becomes problematic, because there's, as you scale up to go to the larger scale, then yes, you get it done and designed over there by local engineers. But on the pilot side, building it here is probably the best.
We can build it and then test it, and
yeah,
a lot of times we'll containerize it, so container ships are easy to bring to port. And although there's been some delays out there these days, so sometimes we've made the pilots in sections and actually put them in an airplane. So they're at a size that's very manageable, and we like to build it all locally so that we can make sure it's truly turnkey. So we can actually put all the piping, the pumps, and the vessels, and then all the wiring and automation, and either test it with water or some real fluids to make sure that everything checks out. So it's pretty common process to do, and if you're doing turnkey, you have to test it out.
Let's say there's a client in Europe or United States or wherever else in the world that wants to use the technology, and we are behind the pilot, and they want to build a commercial unit. Would Exergy be involved in consulting or helping build a commercial unit, or is your role just on the pilot side?
What happens typically is we'll be what you call owner's engineer. So if they're now building the pilot somewhere in Europe and there's an engineering firm there that wants to build it at scale, we'll take certain disciplines of our engineering team and second them to the customer so that there's a continuity of knowledge. So essentially, they'll get dispatched to the customer, and they'll work collaboratively with the local EPC to build things at scale. So we do things up to maybe a pre-commercial scale or like a sizable field pilot, But if it's become commercial, typically we'll find an engineering partner in the region to work with. Would you say, Derek?
Yeah, there's like once it goes up to that commercial and gets up to the, hundreds of millions of dollars or whatever that final commercial scale is, we would basically set what's called the design basis and basically tell that engineering company, here's the flow rates, here's the temperatures, the pressures, here's what's going to happen. How it gets put together and how it gets laid out and the codes everything's built with, that's going to be left up to you guys. But we'll be there for consultation if hey, is this meter going to work or is this component going to work? That's when we would get back in there and say, yeah, we'll help you with that and do up the data sheets that you require.
The components that are required to build the pilot or build the commercial unit, are these some exotic components that have to be made, or are they like widely available components?
There's only one, or on the Aduro side, there's only one or two components that are, I'd say, custom. The rest is all, finding that fit in industry that is what you need. So it'd be like any of the pumps and the vessels and the piping, the electronics, the control gear, all that already exists out there in some form, right? You just have to find the right one. There's only the reactor and some of the recovery technology. I can't go into details on that, but that requires a little bit of special metallurgy and a little bit of special attention to it. But again, we would help with those drawings, help with that metallurgy selection, and go to a trusted fabrication shop and say, let's work together and get this to something that we can definitely build at this scale.
Are there any final thoughts that you guys might have on, Aduro's technology, your relationship or your into with this process before we finish this interview?
Yeah, I would say that it's been great working with the team. I mean, they're collaborative, and just last week or this past week, Derek was in Ontario there for a week, and we're willing to work together, and move around to do whatever it takes to get the job done with them. So, Derek, you're closer to the action. So what are you seeing? I'm
seeing like they're it's a very dynamic team. They've got a lot of great guys on the technology development side, and they're getting a good team going on the engineering side inside. And of course, they've got their management team, which is, whenever you develop new technology, you're kind of pulled 1,001 different directions. So they seem to be managing it quite well. And even though there's late nights and early mornings, they're still pulling through and getting stuff done for us. So it's good.
Yeah, that's always the case with technology development. You have to kind of go the extra mile. Even this weekend, our team is working on a customer's pilot over the weekend, and because they asked to get into a plane here shortly. And I mean, what I find specifically really interesting about is our team gets really energized. We have a pretty young team of engineers and some very experienced people with PhDs and master's degrees, but the young people get really fired up because they're working on a technology that can, get rid of plastics, or, that's good for the planet. And I think that's a big factor too. So anytime Exergy, sometimes we work on things that are more oil and energy and bitumen based, and then we work on something like this, and everybody gets pretty excited. So we're really happy to work with Aduro, and we're really hoping to help them be successful.
Well, thank you very much, guys, for your time.
No, thank you.